Alright, I welcome every one of us once again. Very happy seeing you guys again. As you know, we have been talking about sequence and series for a long while now. And if you're just joining us, you will do yourself good by going back to the previous episode that we have considered in order to understand the concept and from our line of analogy where we are coming from. Alright, so today let's quickly go to the classroom and see what we have today, because we want to be looking at miscellaneous question 1. Let's see how some questions can be set outside the norm that we are used to. Alright, so miscellaneous question 1, it means that I will also come up with another class for miscellaneous question 2 when the time is right. In question 1, we are told that in an arithmetic progression, the 8th term is twice the 4th term. The 8th term is twice the 4th term. So by now, I'm sure that we are used to questions that will lead to simultaneous equation. Alright, because we're not given the sequence, we're not given the sequence of the term for us to know the first term and of course the common difference. So we're told that 8th term is twice the 4th term. So what is the 8th term? A plus 7D is equals to twice, means times 2, into the 4th term is going to be A plus 3D. Alright? So we already know that this is going to lead us to simultaneous equation. What do we do? Instead of leaving like this according to equation 1, let's simplify to the lowest form because we have A and D on both sides of the equation. So we have A plus 7D equals to 2A plus 2 times 3D will give us 6D. And if we collect like terms, we are going to have 7D on the left minus 6D if 6D crosses over equals to 2A on the right minus A if A crosses over. We are going to have D is equals to A. So I'll call this the equation 1. Alright, so this represents the equation 1. Then what are we told again from the question? And the 20th term is 40. 20th term is going to give us A plus 19D. Alright, equals to 40. And this is equation 2. Now we will put equation 1 into equation 2 because already we are having A and D in equation 2. So we will put A, wherever we see A in equation 2, put D there. We can say that D plus 19D equals to 40. 20D is equals to 40. What's our D? Our D is 40 divided by 2 divided by 20, which is written as 2. And of course, since our A and D is equal, that's also equals to our A. So question A has been answered. Our first term is 2. Question B has also been answered because we got that one first. So our question B, D is equals to 2. Alright, is that taken? Alright, perfect. Okay, so the next thing now we go to find is the sum of the 8 to the 20th terms of inclusive and exclusive. Alright, so we have two different scenarios here, inclusive and exclusive. So let's find the sum inclusive. So I will say inclusive sum. Alright, the inclusive sum. What is inclusive? Inclusive means that we are including the boundaries. Alright, the boundaries of 8 and 20 are included. That's what we mean by inclusive. Alright, so that means sum 8 to 20, okay, sum 8 to 20 should be equals to sum 1 to 20 minus sum 1 to 7. We have done all that before, but I'm not going to follow this approach. Alright, I'm not going to follow this approach because I've explained this concept before. Because this approach will make me, I will have to solve this one, okay, get the answer, solve this other one, get the answer before doing my subtraction. So I'm not following this approach. Alright, so I'm going to follow a different analogy. But all I know that I'm looking for sum 8 to 20 because they say the 8 to the 20th term inclusive. So include the 8, the boundary, and include the upper boundary 20 also. So how am I going to solve it is the question. Now, the way it's going to be solved, first of all, when we are adding from 1st to 20, we normally add from number 1, 2, 3 to the 20th term. But now, I want to add from the the 8th term to the 20th term, and because I want to add from the 8th term to the 20th term, it's not a new phase of addition. Because when you add from the 1st term to the 20th term, you will normally use your 1st term to start adding from. You not add the 2nd term, the 3rd term, and so on and so forth. But I want to add from the 8th term to the 20th term. So my 8th term now will now serve as a pseudo 1st term. Okay, not the original 1st term, but a kind of a modified 1st term, because I am starting from the 8th term now. Okay, so instead of using A, I will call it A asterisk. So my T8, so I need to find my T8. My T8 is A plus 7D, and A is 2. That will give me 2. 2 plus 7 into 2. D is 2 also. That will give us 16. So my T8 is equals to 16, and that is equals to A asterisk. That is a pseudo 1st term, because I'm actually starting my addition now from the 8th term to the 20th term. Just imagine it like in a republic, maybe in a particular country. They say this man is the 4th president of the 3rd republic. All right, he is not the 1st president since the history of leadership in that country. Okay, there has been a 1st republic. Somebody was the 1st president here, and many other people were also president in that 1st republic. Maybe perhaps there was a civil war or whatever, or an overthrow of government. Another republic started. So, which they call 2nd republic and 3rd republic, and so on and so forth. So, the 1st phase is gone, 2nd phase is gone, 3rd phase is the man. So, the person that is starting there is called the 1st from the 3rd republic, but he may even be the 100th from the 1st republic, though he's starting at the 1st from the 3rd republic. So also our T8 is the 8th term from the beginning, all right, but it's actually the 1st term from the 8th. When you want to add from the 8th to the 20th term, that means you have to add it first. Okay, so you get the concept now. All right, so that will serve as our 1st term. Then the number of times we are going to use, what is it going to be? Now, many of you may do 20 minus 8 and say it is 12. No, it's not 12. Why does it say it's not 12? Or some might say, okay, they want to be careful. I'll count from 8 to 20. Those people will get it correctly when you count from 8 to 20. But how about when they give you the sum of in-between numbers that are so that, let's say, from 13 to 560? Will you not start counting from the 13 manually, 13, 14, and not to know how many times are there? No, if you won't do that now. So what do? We normally use simple maths to understand complex maths. Alright, so let's go back to the first one we normally do. Normally when we say sum 1 to 20, okay, the first 20 times, what we normally do, we say the number of times there is 20. Why? When we do 20, which is last one, minus 1, we actually have 19. But we need to add 1 extra. Okay, we need to add 1 extra to make it 20. That's how we get that n equals to 20. Or when you count manually from 1 to 20, you actually have 20. So, but the mathematical analogy is 20, the upper boundary minus lower boundary is 19, then plus 1 to give you 20, number of times 20. So, in similar way, I will now use that same mathematical or that logical analogy to get my number of times as saying 20 minus 8, okay, plus 1. And 20 minus 8 is 12, plus 1, 13. So my n is equals to 13. So the number of times I'm going to use is 13 now. And this is my first term. The common difference, of course, for all of them doesn't change. The common difference is 7. So what we have from Sn equals to n over 2 into 2a plus n minus 1d. Alright? So we substitute our x 8 to what? 8 to 20 is equals to n is 13. 13 over 2 into 2. This is my pseudo first term, not the original first term, because I'm adding from the 8th term now. Multiplied by, that is 16. The pseudo first term is 16. 16 plus n is 13 minus 1 multiplied by common difference of 7. Alright, so when we solve, we are going to have 13 over 2 into 32, and of course, plus 84. So when you simplify this finish, what do we have? If you use the calculating device, you discover that the sum of the 8th to the 20th term is equals to 364. So this has saved me the stress of looking for the sum of the 1 to the 20th term, looking for the 1 to the 7th term, and doing subtraction. I just did only one sum, and this analogy save me that stress. Is that understood? Alright, perfect. So take note. So there are different ways you can solve mathematics so long as it's consistent. Then the next one is exclusive. Exclusive sum. Okay, how do we get exclusive sum? Exclusive sum implies that we are not including the boundary, we are excluding the boundaries 8 and what? 20. That means we are starting from, if we exclude 8, that means we start from in between 9 and we end at 19. So that implies that we're looking for sum 9 to 19. And in similar way also, if we define our sum formula Sn equals to n over 2, as already defined, 2a plus n minus 1d. If we have defined it this way, this first term, since we want to add from the 9th term to the 19th term, so what will now find the pseudo first term? Okay, we now have to find the pseudo first term and say t9, because I'm taking from the 9th term, okay, which is actually a plus 8d, okay, is equals to a is to the original first term plus 8 multiplied by common difference of what? What was our common difference now? Our common difference was also 2, okay? Then what we have 18. So can I say that implies that our T9 is equals to 18, and this is the pseudo first term for adding from 9 to the 19th term. Alright, so the number of terms also is going to be gotten the same way. 19 minus 9 is 10, then plus 1, you have 11. So n is equals to 19 minus 9, okay, then plus 1. That will give us 11. And of course, you know why I got 11 and why I do that in similar analogy with when I'm adding from the first 1 to 20 or the first 1 to 10. I'll say 10 minus 1 is 9, then plus 1, I'll say have my 10 back. Alright, so that is where we get this 11. When we put into the formula there, what we have? We are going to have our sum 9 to 19 is equals to n is 11 over 2 into 2 multiplied by pseudo first term, which is what? 18. Alright, which is 18 plus our n 11 minus 1 multiplied by a common difference of 2. So 11 minus 1 is 10 times 2, you have 20, and 18 times this is 36 plus 20, of course you know what it is, then you multiply by 11 over 2. So when you simplify finish, you are going to have sum 9 to 19, alright, it's going to give us 308. So this is the way it's been done. Please take note that when you are solving your calculator, solve this one separately, add the 2, they're both inside the bracket, alright. So you add the 2 before you multiply by 11 over 2. So you have this 308. So this is what is meant by inclusive and exclusive. Alright, inclusive means adding the boundaries, including the boundaries. Exclusive means neglecting the boundaries, start in between the boundaries. Alright, start after the initial boundary and end before the final boundary. And of course, you can see I have followed the shortcut of finding the sum of in between terms. Is that taken? Question 2. Alright, so here is the question 2. The 5th, the 6th, the 7th to the 300th terms of a linear sequence are all these respectively. Calculate the value of k. Okay, so if you look at this sequence, we are not told the 1st to the 4th, but we are told from the 4th. So it means that some terms actually came before, then the 5th now came, which is 3k plus 2. Then the 6th now came, which is now 4k plus 3. The 7th came, which is now 9k minus 20, and thereafter it continues again, which we are not told. Alright, so if you have been following up on the series from the very onset, you discover that our nth term of a linear sequence cannot help us at this point, okay, because we are not looking for any of these variables defined in our nth term, so we don't need this. What do we need to solve the problem? Of course, we now make use of the principle of AP, which is the common difference is constant. So what is common difference? This middle one minus the one before it, which is now 4k plus 3 minus the expression 3k plus 2. and you can see I'm closing it in a bracket because this minus is minusing the entire expression, is the same thing as another person can be doing 9k minus 20, this expression minus this other one, minus 4k plus 3. So that is what we have. And when we expand our left hand and our right hand side of the equation, the first one on the left hand side has nothing attached, so we just open up the bracket, 4k plus 3. Okay, minus is attached to the second term, so use minus to expand. Minus times 3k will give us minus 3k, and minus times plus 2 give us minus 2, equals to, on our right hand side, the first one has nothing attached, so we have 9k minus 20, and the second term has a minus before it. Using the minus to expand, you have minus 4k, okay, and minus plus 3 will give us minus 3. Collecting like terms, 4k minus 3k will give us k, 3 minus 2 give us plus 1, equals to 9k minus 4k will give us 5k, minus 20 minus 3 give us minus 23. And of course, this one come over here to become positive, minus 23 come over here, become positive, k come over here, become negative. So we have 1 plus 23 is equals to 5k minus k. Alright, of course, when you finish up, you're going to have 4k is equals to 24, and k, our k is equals to what? 24 divided by 4. So therefore, our k is equals to 6. So now we have our k to be equal to 6. What then do we do? Now, for us to solve the next problem, let us define some of the parameters that are given. Now, the fifth term was given to us. The fifth term is equals to, because we need the common difference and other things. So, the fifth term was given to us as 3k plus 2. And when we put the value of k, 3 times 6 is 18 plus 2, we have 20. The sixth term was given to us as 4k plus 3. Okay, when we put k equals to 6 there, 6 times 4 is 24 plus 3, we have 27. So you can now see that our common difference now, the 6th term and the 5th term will give us our common difference. Our common difference is equals to 27 minus 20, and that will give us 7. So we have a common difference of 7. Now what's our first term? That implies we can use either the 6th term or the 5th term to solve. Our common, to find our first term now, our 5th term is a plus 4d, alright, which is equals to 20. I've already gotten that as 20. So when you put your d, which is what? Our d is 7. A plus 4 into 7 is equals to 20. And 4 times 7 is what? 28. So a plus 28 is equals to 20. So when this one goes over there, become minus. A is equals to 20 minus 8, which is equals to minus 8. So our first term is minus 8. Alright, is that understood? Alright, perfect. So what are we asked to find in the question? In the question, we're asked to find the sum of the 19th to the 35th terms. Alright? So we use the principle I just mentioned, I just explained now. So that implies that the T19, so if I'm doing from the 19th term to the 35th term, it implies that the 19th term will serve as the pseudo first term, okay, from which we're not adding to the 35th term. So we need to find that pseudo first term, which is 19th term. So T19 is equals to A plus 18 what? D. Alright? And that will give us our A is minus 8. Minus 8 plus 18 multiplied by 7. So that implies that our 19th term is equals to our pseudo first term, okay, which will now give us, solve this with your calculating device, you have 118. Alright, so what's our number of terms? We are adding from the 19th to the 35th terms. Okay, so number of times going to give us n is equals to 35 minus 19, and we plus 1 to it. Alright, 35 minus 1 plus this minus 19 plus 1 will give us 17. Alright, so we have our number of terms is 17. So that implies that from Sn equals to n over 2 into 2a. So the A is the pseudo A, then plus n minus 1d. So we now substitute sum 19 to 35 is equals to n, which is 17, divided by 2 into 2 multiplied by 118 plus 17 minus 1 multiplied by 7, common difference. So of course, with your calculating device, you should be able to solve this. 17 minus 1 is 16 times 7, you have 112, and of course, so this one you are going to have 236. So you're going to have sum 19 to 35 is equals to 17 over 2 into 236 plus 112. And when you finish up, what do you have? You can say therefore that sum 19th to the 35th term is equals to 2,958. So that is the answer we get. Number 3 question in the same listing. What is it telling us to find? Question C. The sum of the last 20 terms. The last 20 terms. Now some students will quickly and in a hurry do, since there are 300 terms, 300 minus 20 will give us 280. Now say, okay, it's from the 280 to the 300 terms. It will be wrong. Why will it be wrong? 300 minus 280 is 20. Plus 1. When you do plus 1, I'm going to be having 21. So it's not consistent with our n. The number, our number is supposed to be 20 because they said the last 20 terms. So our number is supposed to be 20. But when you do 300 minus 280, that is 20. But when you add plus 1, as we normally add plus 1 here, to get the difference, when we do the difference then plus 1, you now exceed, you now be doing 21, which is now against the question that said the last 20 terms. So actually, we are starting from the 281 term because 300 minus 281 is 19. Then when you add 1, you have 20. So our n is 20, as stated by the question. But we are not looking for sum 281 to 300. That will make it to be the last 20 terms. So we now need our pseudo first term, alright, which is equal to the term of the 281. The 281 term will now serve as the pseudo first term because we want to start from that particular point and reach 300. So T281 is equals to A plus 280D. Okay, and A is what? Our A is minus 8 plus 280 into D is 7. So when we solve this, what do we have? Use your calculating device, please. Alright, so our T81 is equals to 1952. Alright, so this is what we have. So if we still use our sum equals to n over 2, you see, I'm always writing the formula. The more you write it, the more you get used to it. Okay, so if we use our sum formula, that means our sum 281 to 300 is equals to n is 20 over 2 into 2 multiplied by pseudo first term, which is 1952. 1952 plus 20 minus 1 multiplied by 7, which is our common difference. And of course, solve this one first. 20 minus 1 is 19 times 7. Then, of course, multiply also this one. Then add the two answers together. Solve this. You multiply this. You add before you now multiply by 10 because the answer is 10. 20 divided by 2 is 10. So, we can now say that therefore, that our sum 281 to the 300th term, okay, is equals to 40,370. So this is how it is gotten. Any question? Alright, no question. Let's look at the next question now. Question number 3. In question number 3, we are told that the first, the third, and the ninth term of a linear sequence are what now? The first 3 terms of an exponential sequence. So, reading this question, why our linear sequence are not in consecutive order? Because they said the first, they now jump the second, I went to the third, now jump others, I went to the ninth. While the linear sequence are not in consecutive order, the exponential sequence are in consecutive order. So now say the first of our linear sequence is always A, and is equals to the first term also, corresponding to the first term of our exponential sequence A. Alright, so we don't have problem with this one. A is equal to A. Alright, we know that A is equal to A. 5 is always 5. Alright, so we now take next one. The third term corresponds to the second term because it's the first 3 terms of an exponential sequence. So the third term of the linear, which is A plus 2D, will correspond to what? The second term of an exponential sequence, AR. I'll call this equation 2. Alright, and again, the ninth term, which is what? A plus 8D will give us the ninth term, will correspond to the third term of the exponential AR squared, equation 3. And we're now told again, if the seventh term of the linear sequence, seventh term is A plus 6D, which is equals to 14, equation 4. Alright, so we have this equation here. Now, the first one don't really make much sense. Where the problem is the third to the second to the fourth, which is like 3 equations and 3 variables. So we are in order. So how do we solve this problem? Now what we'll do here, if we use our principle of linear equation, common difference, we cannot solve this problem because we are not told that the linear sequence are in consecutive order. They are not from the question because you have the first, they jumped the second and went to the third. But the exponential sequence are in consecutive order because it is the first 3 terms of an exponential sequence. Alright, so since the exponential sequence are in consecutive order, so that means our common ratio R can actually be defined. How do we define our R? Our R is this one. Okay, we can say this one here. This one is not part of them. This one is just the linear sequence alone, equals to the seventh term of the linear sequence equals to 14. Alright, that is what this particular statement, the last statement said. So it didn't say that it didn't say that this one is a relationship between the linear and the exponential. That is just a relationship between only the linear. So our common ratio now is this equation 3, alright, this one divided by this, which is the third term divided by the second term, A plus 8D, okay, which is this third term, divided by the second term, which is A plus 2D, A plus 2D, is the same thing as another person can also do this, our second term divided by the first term. The second term in the exponential divided by the first term, which is what? A plus 2D divided by A. Alright, now we are dividing this side because the right hand side is in exponential, but this exponential is the same thing as this. So instead of putting this, I put this. The same thing, this one is also the same thing as this. So instead of putting this, I put that. So that is what is happening here. When we cross multiply, we are going to have A plus 2D multiplied by A plus 2D is equals to A into A plus 8D. Alright, and when we expand, we are going to have A times A is A squared, and of course, if you expand this, you are going to have A squared plus 4AD, alright, then plus 4D squared is equals to A times A is A squared, and when you times A times 8D, you are going to have 8AD. Alright, so when we collect like terms, this one come over here, we are going to have A squared minus this A squared, this one come over become minus, then plus 4D squared is still on the left, equals to 8AD on the right minus 4AD. This one going to the right to become minus. A squared will cancel A squared to give us 0. They will now have 4D squared is equals to 8AD minus 4AD will give us 4AD. 4AD. Divide both sides by 4D because 4D is common. So we are going to have 4D squared divided by 4D is equals to 4AD divided by 4D. Okay, 4 take away 4, 4 take away 4. D cancel D, we have A, and D will cancel 1D here, remain D here. So we cannot say that therefore our D is equals to A. So since our D is equals to A, Okay, now put this equation star into each equation now. Equation 4. Alright, put it to equation 4. So whenever I see A now, I'll put D. So instead of A now, D plus 6D is equals to 14. 7D is equals to 14. What is our D? D is equals to 14 divided by 7, which is equals to 2. And that is also equals to A because they are equal from equation star. Is that understood? Alright, so what is the next question we are asked to solve? The 20th term. We cannot find the 20th term now. Okay, which is question A, 20th term. So question A, T20 is equals to A plus 19D, and that will give us 2 plus 19 into D is also 2. Alright, and that will give us, so can I say the 20th term? Therefore, the 20th term is equals to 40. What is the next question? The next question says the sum of the first 12 terms of the exponential sequence, not of the linear sequence. Please always read very carefully. So now sum is equals to A into 1 minus R raised power n over 1 minus R. Any formula I want to use. What is our common ratio? We need to find that. Whenever you write a formula and you don't have all the parameters to solve it, it means that you are required to find those parameters to finish up. So what's our common ratio? So let's go back to our equations. We can use either equation 2 or 3 where R appeared. Okay, so let's use equation 2 because it doesn't have a parenthesis. It looks simpler. So A plus 2D equals to AR. So I'll now say, but A plus 2D is equals to AR. Our A is 2, 2 plus 2, our D is also 2, is equals to A is 2, 2R. This is 6 equals to 2R. That implies that our R is equals to 3 if you divide both sides by 2. So now I have my R, I have my A. What is my N? They ask me to find the sum of the first 12 terms. So N is equals to 12. So N is equals to 12, while my A is equals to 2. So when we substitute, sum 12 is equals to 2 into 1 minus common ratio 3 raised to power 12, okay, over 1 minus 3. And that will give us 2 into 1 minus 3 raised to power 12 over minus 2. Okay, 2, we eliminate 2, you have minus 1 under, and anything divided by minus 1 will give us minus. So have sum 12, 1 to 12, give us minus into 1 minus 3 raised to power 12. If we use our minus to expand, of course, I want to leave it at this. Sum 12 is equals to minus times 1 give us minus 1, and minus times minus will give us plus. So now have it as 3 raised to power 12 minus 1. So this is the way I'm leaving it. You can use your calculator and finish it up. Alright, so this is where we are going to stop for this episode. Here is your practice question. So for the first one, you can quickly know what it's going to give you, but I'm going to help you for that first question. Alright? Your D is equals to 3 over 4A. So for this one, your D is equals to 3 over 4A as your answer. So, but verify that, solve and verify. But for this other one, the question B part, I will just tell you what to do. Okay, they say this one has to do with proving. You have to show that 21st, 37th, and the 65th terms of the linear sequence are consecutive terms of the exponential sequence, whose common ratio is this. So what that means is find the 21st term, the 37th term, and the 65th terms of the linear sequence first. Find them. After finding it, if you divide the 37 by 21st, and it gave you 7 over 4, I also divide the 65th by the 37, it also gives 7 over 4, then you have proved it. That means that this sequence, 21st, 37th, and 65th of the linear are actually consecutive terms of an exponential sequence. So that's what I'm talking about. So you have to prove that one by yourself. So this is where we draw the curtain for this episode. And also use this opportunity to also say that for the math scheme, the ordinary mathematics, that this is also where it comes to an end. Alright. However, I will still upload miscellaneous questions on AP and GP, okay? Because further math students have not also done recurrent sequence, okay? Recurrent sequence is also part of our sequence and series. So because of the additional mathematics students, I'm going to go further in also taking recurrent sequence and also uploading further miscellaneous questions for them to also see. However, whatever we have done from episode 1 to this 11th episode is applicable to both additional mathematics students and students who are offering only pure mathematics. Thank you very much. Have you learned something from this video? If you have, please do subscribe if you haven't. Alright, and also recommend the video to people looking for a study material to guide them systematically how to solve mathematics problem. This is also useful to those who are in high school preparing for their exam. It can serve as a revision text to them. It's also a very handy material for schools that are looking for teacher learning material for students in order to enhance or boost their understanding of mathematics. It is a goodbye from me. Till we see again. Thank you very much for watching.